The Kawasaki Automatic Power Drive System appears in Kawasaki all-terrain vehicles and utility vehicles. It is a continuously variable transmission, a CVT. This video explains CVT construction and operation, general maintenance, troubleshooting common symptoms, and high-altitude tuning. A CVT is a totally automatic transmission that reacts to engine RPM and vehicle load or drag to allow the engine to run in its most efficient operating RPM range. Ease of operation is the CVT's single most important advantage over other kinds of transmissions. A CVT has three main parts: the drive pulley, the driven pulley, and the belt. The drive pulley is mounted on the end of the engine's crankshaft. The parts of the drive pulley are the movable and fixed sheaves, the spider with its rollers, the ramp weights, the wear buttons, the spring, and the cover. The driven pulley is mounted on a shaft which drives the rear wheels through a simple transmission final drive unit, which allows the operator to select high or low range forward, neutral, and reverse. The parts of the driven pulley are the movable and fixed sheaves, the ramp cap, the wear shoes, and the torsion spring. The belt has a V-shaped cross-section and is reinforced with very strong Kevlar fiber cords so that it cannot stretch. What look like teeth on the inner side increase the belt's friction surface area while still allowing the belt to flex easily around the pulleys. A used belt must always be reinstalled so that it turns the same direction as before. Install a new belt so that the information printed on it is readable from the outside. Inside the drive pulley, the ramp weights are pivoted so that they act like the weights of a centrifugal governor. Rising engine RPM forces the weights outward, pressing the movable sheave of the pulley in toward the fixed sheave. The moving sheave forces the belt outward on the sheaves, increasing the effective radius of the pulley. As the drive pulley's effective radius grows, the belt forces the driven pulley's sheaves apart, allowing the belt to ride on a smaller radius. This is the same as upshifting from first to second in a geared transmission. If the load on the driven pulley increases, as when the vehicle starts to climb a hill, the movable sheave rides in on ramps within the fixed sheave, closing the pulley against the belt. This pulls the drive pulley open and changes the drive ratio, like downshifting from a higher gear to a lower one to allow more engine speed for more power. A spring wound around the shaft in the center of the driven pulley controls the movable sheave so that it moves in and out on the ramps smoothly in response to the load applied to the vehicle. The tension of the spring opposes the force of the belt on the pulley. This is briefly how the drive and driven pulleys work together to vary the drive ratio to suit the engine speed and vehicle load. Any mechanical system needs periodic inspection and maintenance, and that means taking it apart and putting it back together again. The periodic maintenance chart in the service and owner's manuals instructs us to check the belt and the driven pulley wear shoes regularly. Proper belt deflection is important to good performance and is adjustable on prairie ATVs. With the engine stopped, measure the deflection by pushing the belt down with a ruler across a straight edge. Compare the measurement to the service limit in the service manual. If adjustment is called for, change the spacers in the driven pulley to bring the belt deflection to the tight end of the specified range. Light grooving at the bottom of the drive pulley won't hurt anything, but if they are so deep that the belt can catch in them, the unit will not upshift smoothly. Replace the sheaves. Use the special tool listed in the service manual to hold the pulleys while removing the bolts, or use an impact wrench. In Kawasaki's ATVs, these bolts usually have left-hand threads. Check the service manual. Thread in the puller and tighten it to ease the pulley off the crankshaft taper. Take off both pulleys at the same time with the belt still on them. Take out the drive pulley cover bolts. Generally, this cover is under light spring pressure, so hold it down as you remove the bolts. On the Mule 500 and 550 models, remove the fan first, and then take off the snap ring to remove the ramp plate. On the larger Mule models and the early Prairie ATVs, lift out the spring, the sleeve, and the 3 wear guides. Now remove the spider. The split ring locates the spider on the shaft and limits the movable sheave's travel. Take out the halves and the sheave lifts off. 2 bolts hold each roller in. The ramp weights on the spider are mounted the same way. On the Mule 500 and 550 models, the weights are rollers on spring-loaded arms. Pry the ends of the springs off the tabs on each arm. Take out this bolt to remove the roller. Also on these models, the spider is pressed into place. It can be removed with special tools, but if removed, it must be replaced with a new part. Be sure you need to remove the spider before making an expensive and time-consuming mistake. On later model ATVs, the ramp weights may be removed without taking off the spider. Each ramp weight has a bushing inside it that can wear. Check the condition of each ramp weight shaft. Replace worn parts. Special tools are required to remove the spider. One tool holds the drive pulley fixed sheave. The other turns the spider. The spider only needs to be removed to change the rollers, which have bushings in them, and the wear buttons. Check the service manual for where to lubricate during assembly and what kind of grease to use. While it's apart, check the sheave friction surfaces for wear and damage like grooves, and make sure the ramp weights and rollers move freely. If they are damaged or worn, replace them. The movable sheave must slide easily. Measure the inside diameter of the sheave bushing and check it against the service manual. Replace it if the inside diameter is too large. During assembly, be sure to watch for the alignment markings. The pulleys are balanced at the factory, and this arrow must be aligned with this mark during assembly to maintain that balance. The other model CVTs have similar marks. Check the service manual. Before tightening the spider, measure the clearances between the wear buttons and the arms of the movable sheave. Too much clearance can cause a knocking noise at idle. Too little clearance may make the sheave stick and not allow it to shift properly. Now tighten the spider to the torque specification in the service manual. On the larger mules and older Prairie drive pulleys, fit the split ring into the groove. Drop the spider into place. Remember the alignment arrows and slip in 1 wear guide. Use a feeler gauge to measure the spider to wear guide clearances. Too little clearance and the spider can stick and not shift smoothly. Too much and the drive converter makes a knocking noise at idle. Different thickness wear guides are available for some models. Measure the spring length. If it is shorter than the service limit, replace it. Like the bushing in the sheave, the bushing in the cover can wear with use and may be replaced. Remember to align the arrow, then install the cover. Tighten the bolts to the torque specification in the service manual. On the Mule 500 and 550 models, inspect the parts of the rollers and their springs, the spider springs and guides, as well as the sheave surfaces before reassembly. The driven pulleys are simpler in construction than the drive pulleys. This type used on the later ATVs comes apart from the back. During disassembly, first note the spring hole position. Then hold down the ramp against the spring pressure and remove the circlip. Slowly release the ramp and note the hole the spring fits into on the pulley sheave. Write down the hole positions the spring was in. If there is any doubt about these positions, check the service manual during reassembly. The other holes are for tuning the driven pulley's response to vehicle load. Take off the movable sheave and remove the spacers from the bottom of the fixed sheave. The thickness of these spacers controls the belt deflection. Each wear shoe is held by a single screw. To ease disassembly of the driven pulley on the larger mules and early prairie ATVs, you may want to make the special tool described in the service manual. Take out the outer ring of coupling bolts. Do not touch the inner ring of bolts. Lift off the spacers. On the early prairie ATVs, these spacers control belt deflection, so it is important not to change the stack. Turn the sheave to take off the torsion spring pressure, about 45 degrees, and hold it there. Push down the ramp cap, take out the halves of the split ring, and release the ramp cap. Carefully release the sheave and let it slowly unwind, relieving spring pressure on the ramp cap. Pull the cap up and off. Even though there should be no pressure on the torsion spring, be careful that it does not fly out. Take out the spring and lift off the movable sheave. To remove the wear shoes, drive them out from the back. Tap new ones into place from the front side. The Mule 500 and 550 driven pulley also needs a special tool for disassembly. Early models have a left-hand thread nut here. The KAF 300B2 model changed to right-hand threads. Unscrew the fixed sheave with this special tool. Lift off the ramp and its spring. The wear shoes are held in place with a single screw each. Check the friction surfaces of both sheaves for wear and damage, and measure the bushings inside each sheave. Slip the ramp cap onto the splines to check for a smooth, tight fit. The ramp cap surfaces must be smooth and show little wear. The wear shoes inside the sheave develop a flat area as they wear. Measure the width of the flat to determine the amount of wear. Measure the free length of the torsion spring coils. Do not include the tips in this measurement. If the spring is shorter than the service limit, replace it. To put the driven sheave back together, start by fitting it onto the special tool. Drop the spacers onto the fixed sheave shaft. Now set the movable sheave into place. Put in the spring and set the ramp cap onto it, using the same holes that you noted during disassembly. Now turn the movable sheave and the ramp cap together to align the missing splines on the shaft and the ramp cap. Push the ramp cap partway onto the splines. Turn the movable sheave clockwise about 90 degrees and push the ramp cap all the way down. Hold it there, put on the washer, and install the circlip. The assembly of the larger mule and early prairie driven pulleys is very similar, but they have a few more parts. Be sure the tip of the spring is returned to the hole it came out of. Set the ramp cap onto the spring. Be sure the tip of the spring is in the right hole. Turn the sheave to align the arrow on the ramp cap with the mark on the end of the splines. Now push the cap down onto the splines. Keep one hand on the ramp cap while turning the sheave with the other, about 45 degrees clockwise, and hold it there. Now push the ramp cap the rest of the way and fit the split ring halves into place. Be sure the split ring stays in place as you release the ramp cap. The arrows must align with the mark. Put the washers back onto the nose of the coupling. Turn the coupling to align the arrows, then screw in the bolts. Torque these to the specification in the service manual. All of these procedures are covered in the service manual for each model. Some Kawasaki CVT systems differ in detail, so look at the manual before starting work on a model you have not seen before. Troubleshooting a CVT, like any other mechanical device, requires careful observation of the symptoms. Knocking and rattling noises are usually caused by worn parts. The wear buttons and wear guides can cause a knocking sound at idle if they are worn too thin. It sounds like the engine is knocking. The bushings in the sheaves can wear and let the sheaves rattle. This can also sound like a severe engine knock at idle. A quick test of this kind of noise is to take off the drive pulley and run the engine at idle. Sometimes the inner sheave of the drive pulley on early model Prairie ATVs can unscrew during deceleration and hit the inner cover, making a noise. On acceleration, it screws back on and the noise goes away. Performance problems are the most common symptoms. If the performance is not there, the customer is going to bring it back to you for help. Lack of power just off idle can have a number of causes. If the drive belt is worn too narrow, it is effectively longer because it fits deeper into the pulley sheaves. This allows the drive pulley to upshift prematurely. This is like starting out in second or third gear with a geared transmission. With the system starting in too high a drive ratio, the belt slips and wears more. The result is a circle of cause and effect, wearing out the belt very quickly. This problem can start if the operator uses high range for slow going or heavy towing. The operator may complain that the vehicle will not shift to a higher drive ratio. Changing to low range makes it easier for the vehicle and wears the CVT less. The drive pulley movable sheave can wear and stick in an upshifted position. Check the bushings in the cover and the movable sheave. Low top speed can be traced to the CVT as well as to engine power problems. If you know that the engine is in good condition, start with the belt. We have already seen that as the belt wears and gets narrower, it becomes effectively longer and fits deeper into the pulley sheaves. At top engine speed, the drive converter sheaves are as close together as they will go, but still have not pushed the belt far enough out to achieve the highest drive ratio and make top speed. On the Mule 500, the driven pulley can unscrew and come apart because of the left-hand threads. If this happens, the vehicle won't move under its own power. To check on this, look at the belt in the driven pulley with the vehicle stopped. The belt should be all the way out on the sheaves, with the sheaves pressed tightly against it. If there is any play here, the sheaves have unscrewed. Tuning a CVT is based on running and performance symptoms, just like troubleshooting. At high altitude, the engine loses power. This loss can be partially compensated for by tuning the CVT to allow the engine to run faster. Tuning to allow more engine RPM can be done on either the drive or driven pulley. Remember, however, that the action of the pulleys must be matched for best performance. High-altitude tuning of the 1997 and 98 Prairie models is covered in this service bulletin. Note that both the drive and driven pulleys need adjustments, as well as the carburetor jetting. The drive pulley adjustment is partially a reduction in the mass of the ramp weights by taking off washers. In extreme cases, a lighter ramp weight can be installed. The other part of the adjustment is increasing spring pressure by adding spacers under the spring. The only driven pulley adjustment is changing the holes that the spring fits into. These adjustments increase the spring tension, making it harder for the system to shift up into a higher drive ratio, so the engine runs a little faster. The later ATV converter system can be tuned in the same way by changing the ramp weights, the spring in the drive pulley, and the spring hole positions in the driven pulley. Only the driven pulley spring adjustment is available on the Mule 500 and 550 converter, although there are no official adjustment specifications for it. Of course, adjustments like these can change performance at any altitude. Allowing the engine to run faster at a given vehicle speed will increase pulling power at sea level just like at high altitude. There are limits to what you can do, however. Adjusting the CVT so that the vehicle can pull more than specified only means trouble, and it voids the factory warranty. The other components of the drive system are designed to transmit only so much torque and to withstand only so much starting shock loading. In this video, we have covered what a CVT is and how it works, how to disassemble the Kawasaki CVTs, and how to maintain them. Finally, we looked at troubleshooting and how to adjust for various operating conditions. Also, look at the video reference manual. It covers what you have just seen with added detail.